Hello, my name is Simon Good. I'm going to be taking you through the Copernicus Marine Service Sea Surface Temperature Training Python notebook. As I go through the notebook, I will be executing the code in some of the cells using the Shift plus Enter shortcut. You can also select the cells and use the arrow button to get the code to execute. The first part of the notebook is doing some initial setup. Some of this won't be needed while you're using the training environment, but if you are doing this at home, this shows you how to get set up. So the first thing to do is to check that we're using the correct Python version. This command can be run to show that I am using Python 3.7, which is the recommended version of Python for the notebook. If you don't have that version, you can use this command to use the Anaconda package management system to install the version that we want. We also require some Python modules for us to complete the work. The main ones of these are listed in this table. If you need to install these, there is a command here that you can use. We also want to create a couple of directories to contain our input data and our outputs. So this code segment here defines a function that checks if a directory is there and creates it if not, and then it will create the two directories that we want. In this case, because the directories already exist, it doesn't have any effect. The next section of the notebook is about the data that we're going to use. So there's two data sets that we need to get. The first one of which is a foundation sea surface temperature product. So this is the sea surface temperature from which the diurnal cycle grows during the day. It's what we call a level 4 product, so it combines together different satellite and in situ data products and infills any gaps. It covers the global ocean and is provided on a 1/20th of a degree regular grid. If you want to find out more information about the product, there are some links here, and there is also a paper shown here where my mouse pointer is. For the data that we're going to use in this exercise, we're going to want a subset of the product that's available from the Copernicus Marine Service. So this table defines the parameters of that subset. But later on, there is a command that you could just easily use to download the data. A second product that we're going to use is a diurnal SST product. Again, this is a level 4 product, so any gaps in the observations have been infilled. And this is at a 1/4 of a degree grid resolution, and it provides hourly data. Again, there is a paper to read if you want to find out more, and documents available from the Copernicus Marine Service website. The parameters needed if you want to download the subset of data that we will use in this exercise are shown in this table. And now if you want to download the data, one way to do this is with this Python module here, which you can install with this command. And then there is a command here that can be used to download the particular section of the data that we want, remembering to replace here where it says username and here where it says password with your own Copernicus Marine Service login. So that was for the first example data set, and this command here is for the second example data set. I won't run them here because the data are already available in the training environment. And we can check to make sure that the files have been downloaded and are available using this command, which I will run now. And it shows that the two files that were downloaded are there. So now we come to the exercises. The first one of which is going to be map plotting of the first data set that we obtained. So we need to import the Python modules that we need to use. So this is firstly the OS module here, and then we set to ignore some warnings, which we don't need to see, and then we import the remaining modules that we want. There's also a couple of lines here that define a region code and also a notebook code for use later on when creating files, and also a small helper function that gets the indices of the data array between two values, and that's used later in the plotting. Then we define where our data are and where we want the outputs to go. So the output directory is going to have a subdirectory for the region code and notebook code that we defined just now. So we could just do another check to make sure that we've got everything we need. So we've got a listing of the directory that shows we've got the notebook plus the data and output directories. And then we want to also create that subdirectory of the output directory. And we can then check that that's appeared, which it has. And finally, we can again double check that we've got our two data files. Now to read the data, we're going to use a module called Xarray. So first we define the file names. This is the one with, we're going to use the one with A at the end of it, and then use Xarray to open the dataset. Once we've done that, we can easily get some information about the data using the info command, and this tells us that it's got dimensions of 3600 by 3200 with one time point. For example, now we downloaded two variables, one of which is the sea surface foundation temperature, but we also got the sea ice fraction, which is also provided with the data. So just to confirm that, we can list the data variables using this command here, and that just shows again what we have. And we can also get some information about the coordinates using this command. So now we do some definitions. So we set the names of the coordinates that we want to use, and also the variable name of the data that we want to plot. So we could choose here between analyze SST, which is the sea surface temperature, or sea ice fraction, which is the sea ice concentration variable. So to get the sea ice fraction data, you could uncomment this slide here, but I'll leave it on sea surface temperature for this example. And then we could do a plot. So the commands we use here, but you could alter these if you wanted to have a play around with the different settings. For example, you could set the latitude and longitude range of the plot here, and also the range of sea surface temperature values to plot could be set here. So there's a commented out example of that in this line. But by default, we're just plotting the full range. So I've executed that code block, and then this part here is going to do the plot for us. So this is quite a lot of code in here, but it's using the base map module to define the map, and then the imshow command then shows the data here. but you could look through this in more detail if you wanted to see exactly what's being done. So if I execute this command, it'll take a moment, but then we should see a plot appear showing the sea surface temperature, and there it is. As I say, you could go back and try different things to change the plot, such as the area that's being shown. So feel free to experiment. In our second exercise, we're going to plot a time series of data. So again, we're going to do various imports. This part is repeated from the previous exercise so that they can be done in either order. So I'll just quickly execute these cells. In this case, we're going to be using the data file with B at the end of it, the file name. And again, we use Xarray to open the data set. And we can use the info command again to look at the data. In this case, it's a 720 by 640 element array in latitude and longitude. But this time we've got 120 time points. So here we're going to set the variables names that we're going to be used for accessing the data. And then we also need to choose two locations that we're going to plot on our time series plot. So I've just chosen a couple of points here, but these could be changed to anything that you're interested in. And then we can select those data from those points using these commands. And it helpfully gives us, by just saying the name of the variable here, it helpfully gives us some information about what we've extracted. We'll look at this in a bit more detail in a moment, but I'll do the same for the second data point. And then we're going to do a bit of manipulation to get it into a different way of looking at it, which is a pandas data frame, which provides a very convenient way to look at data like this. So this command gets the SST values that we want to look at and lists them there from the first point to then the second point. And then we're going to convert those two things into one of these data frames. And now we can have a look at what the data looks like now once it's in this data frame. So this command here is just going to show us 100 points from the time series. And as you can see, it gives a nice, easy to read output showing the date, which, as I mentioned before, these are hourly data, and the SST for the two locations that we've picked. And we can also use the data frames describe function to give some more information about the data. So it will give us how many data points, the mean, standard deviation, etc. And we can also resample the data to do daily means using these sets of commands. And then that will print out the daily mean on each day. If we wanted to save the data out to be used later on, we could, one way to do that is to write it as a comma separated variable file. This gives an example to do that. And finally, we want to do a plot showing what the time series look like at those two locations. So if I execute this command here, it will show us the plot. As you can see, we've got the hourly data and the daily average shown on there for the two different locations. And both those, this plot and the one that I showed earlier, will get saved out to the output directory. So there's various things you can do to change the plot. For example, you could try changing the locations being plotted, could download a longer time series, do things like look at the daily minimums and maximums. So this is the end of the Python notebook for the sea surface temperature. I hope you found it useful and enjoy experimenting with the data. Thank you.